this time. Worksheet 5, we are finishing section 2.3. All we did yesterday was discuss long division and synthetic division. We didn't really apply why we would have to know that, okay? The rest of this lesson is on why we use it. Here's a big why we use it. It's to factor polynomials. The directions up here for number 8, which was an assigned homework problem, were to factor each polynomial completely using the given divisor and long division. Okay, so this is the horrible, nasty problem that was number 8. I have written it here. If you have not started the homework, take a second to copy that down and attempt to do the long division, please. Piece of notebook paper, please. If you have not started this, try it. I'm expecting everybody to hand something in because I'm going to do 3 or 4 of the homework problems together with you today. If you already did it, good job. Esmeralda, I'm thinking you're one who started it, yes? What did you start with? Up here, an x squared. And then when you multiplied it through all of those, you got? Okay. And then hopefully you remembered we are subtracting. We're adding the opposite of all those, and like I said before, guys, I suggest you just go ahead and use a colored pencil and switch colors when you have to do that, but so now when I add, I have a 1x cubed and a minus 24x squared. Is that what you had, Esmeralda? Did someone else get that? Negative 36 plus 12x squared is negative 24. We good? All right, that's an 8. Kind of looks like a 9. Anybody want to tell me the next step? Yep, we need to multiply to get an x squared to become an x cubed by a positive 1x, or just an x. That'll give us x cubed minus 4. X squared minus 12x. Who's lost? Nobody's willing to fess up? Okay. I am subtracting or adding the opposite of all these. So I now have negative 20x squared plus 80x plus 240. Anybody get that for that step? Okay. We got to bring this guy all the way down. All right. What does x squared need to multiply by to become exactly negative 20x squared? So negative 20 up here will give us negative 20x squared plus 80x plus 240. Thanks. Noah, Amela, and Madison, you have papers to grab up here, Maddie. Sorry. Now if I go through and change all these to add the opposites, I get 0. All right, but the question, remember the directions were kind of funky. It said completely factor this. Okay, so if I were checking this question right now, I got as an answer x squared plus x minus 20 when I divided by x squared minus 4x minus 12. Okay, great. I could foil it all back together if I wanted a headache, and it should go back to this. But the issue is, how do I completely factor now, and why did that help me? I had no idea how to factor that original polynomial. But now that I know this divided evenly in here, can I factor those two trinomials? Because they're both squared, right? So this one will factor plus 5 and minus 4. Does that seem right? Give me a 1 in the middle. And how will this one factor back here? Minus 6 and plus 2. Is that right? So I get a negative 4 in the middle? Okay. Now, if I were to divide by any of those 4 things by synthetic division, what should the remainder be? 0, right? Because we just said it factors that way. Now, if I were to graph this original horrid degree 4 polynomial here, where should the zeros all be found at? Negative 5, positive 4, positive 6, and negative 2. And it was a degree 4 with a positive leading coefficient. So the graph should be doing something crazy like that. You don't have to sketch that as part of the homework. I'm just trying to tie all the parts of what we've been doing together. Does this seem okay? All right, so that was using long division to factor when they gave us one of the things that we should divide by. I have an extra practice on long division. Do you need me to do one more? Some of you maybe. You don't have this one. This is just kind of a warm-up. I don't think you do anyway. It says somebody want to come to the whiteboard and do it. I don't really know if my smartboard is calibrated. Does somebody want to try it? You want to just tell me what to write?
Sure.
Okay. Good job.
That means you do x times 3x, which is 3x squared, and x times negative 2, which is negative 2x. And then you subtract that whole thing.
Okay, so subtract, and this will change to add.
And from that, you just have a 6x. And drop down another 12. In order to get 6x, you have to multiply by 2.
And when you write that up there, guys, make sure you write it as a plus 2 because this is a polynomial. It's not times 2, okay? Go ahead.
2 times 3x, subtract that whole thing. And you want to just add a negative 8 for that. So your remainder is negative 8 over 3.
Yes, if we're asked to write it as a fraction, okay? Perfect. Everybody remember all that from yesterday? Okay. We are going to move on today and talk about the remainder theorem. The remainder theorem is just a way for you to really, in my opinion, at this point, it's a way for you to check answers or to have options and choices about how you solve something. The remainder theorem says that if you have a polynomial and it's divided by a linear factor, do you remember what it means if we can do dividing by a linear factor? It means we don't have to do, if it's a x minus, so there's no stretch out here, we don't have to do long division, right? We can do synthetic division. If you do, you can do synthetic division, and the remainder will equal the same as if you actually put c into the function. So real quick, if I had x squared minus 3x plus 7 and I wanted to divide it by x minus 1, I could predict the remainder by putting f of 1 into this equation up here. So I'd get 1 squared minus 3 times 1 plus 7, which would be 1 minus 4 is negative 3 plus 7 is 4. So that means I'm going to do synthetic division, guys, real quick. Remember this from yesterday? What goes in the box? Thank you. 1 minus 3 is negative 2 plus 7 is 5. Thank you, because I would have had a big mess in a second when I tried to prove how that theorem worked. All right. X minus 1, what goes in the box? If we're going to do synthetic division, the positive 1, the 0. Across the top, if I'm dividing it into this, would just be 1, negative 3, and 7. Bring this down, multiply, add, add. And do you see that putting it in predicted the remainder? Okay? So the same thing is true if you want to know if it goes in evenly. If you want to know if something is a factor and divides in evenly, you could put the 0 in, and what should you get out from the function? A 0, yes? The remainder should be 0. All right, this is where they decided would be a good example to use this. You guys see what you think. The number of tickets sold during a high school football season is modeled by, sold during the high school football season can be modeled by this, where X is the number of games played. Use the remainder theorem to find the season of the number of tickets sold during the 12th game. So they're saying we could put a 12 into here to figure out how many tickets. But they decided it would be faster than typing a 12 in all of those places to do synthetic division. So they put a 12 in this box and did 1, negative 12, 48, and 74, the coefficients, brought it down, multiplied, added, and they got this remainder. That is the same thing they would have gotten if they did direct substitution. I don't know about you. I have a calculator. I think I would have just put the number in. If I could do it all in my head, it would be one thing, but I don't know 12 times 48, so I had to get my calculator out anyway, right? It just feels more natural to me to put a 12 into the equation and get the answer out. They're just showing you there's an alternative. So the factor theorem is just a corollary of the remainder theorem. It follows directly from the remainder theorem. It says if x minus c is a factor, only if and only if you can put it into that c value, the 0, into the function and get out a 0. In other words, if you divide and the remainder is 0. All right, so you have this question on your notes, and we're going to solve it 2 different ways. It says determine whether x minus 2 is a factor of this polynomial. So the first way is to use substitution to substitute a 2 directly into this function. So we'd have 2 times 2 cubed plus 5 times 2 squared minus 14 times 2 minus 8. I'm getting 0 in my head. Is anybody else getting it on the calculator? Yes? Yep. Okay. So if we found out this is 0, should x minus 2 be a factor of this? If the remainder is 0, then yes, it comes out a factor, okay? So is this a factor? Yes. Because the remainder is 0. That's what this is telling us. The other way we could have done it is to actually do the division. Now help me, because I went fast through that last synthetic division. What goes in the box if we're dividing by this? The 0 value, which is positive 2. Across the top would be what numbers? 2, 5, negative 14, and negative 8. No placeholders needed, right? Was degree 3, 2, 1, and no x's, so we were good. Okay. The first one just drops down. Then what? 2 times 2 is? Add. 2 times 9 is? Add. 2 times 4 is? Add. Okay. So Is x minus 2 a factor? Yes, because the remainder was 0. Do you understand that those two things, you can do it either way? Okay, you can plug the number in, or you could do synthetic division to prove it's a factor. Now, I think on the quiz there's a question that says, show synthetic division to determine if it's a factor, and then it asks you, yes or no, is it a factor? And you'd say yes, because I got a remainder of 0, or no, because I got a remainder that isn't 0. Now, the other thing they're going to talk about today is, what does this represent? We just did this on a question at the beginning. We said this is, well, we did long division, I apologize. This was the remainder. This is the constant term, right? Doesn't get an x. This one gets an x, and this gets an x squared, and we need some signs in there. This is positive and positive. So the remainder, or I'm sorry, what's called the depressed polynomial, after we have divided. Yes, that's me today, I think. After all my troubles with my smartboard. This is the depressed polynomial. So now, if we wanted to factor this completely, could we? We know how to factor a quadratic, right? We hopefully do. 2x and x, 4 and 1 would make 8, and 1 would make 9 in the middle. Okay, the thing to do when you have to check, when you have fully factored, which was not part of this question, I'm just trying to tie it all together, the thing to check when you're fully factored down here is that you would still get the same leading coefficient, because I'm going to show you that we can do this and not wind up with the right leading coefficient sometimes. Okay, x, 2x, and x. Did we get a 2x cubed? Okay, so we were good. All right, problem number 4 on the front. Did we actually do this problem yesterday? Okay, go back and do that real quick, please. Uh-oh, what are we going to need this time? Placeholders. Please do number 4 on the front. There's going to be a bunch of placeholders we need, I think. We have a 1x to the 4th, a 0x cubed, a negative 3x squared, a 0x, and a 12. I feel like I did something wrong. Did somebody get 10? Okay. As the remainder? All right, so can you tell me what this polynomial was? X, let's see, this was a constant. This one gets an x, x squared, x cubed. So it was x cubed plus x squared minus 2x minus 2. With a remainder of 10 over the divisor, x minus 1. Yuck. All right. Flip back over to the back if you have that done. On the back of the worksheet, how could we check this answer? How could we have checked this, that we did this right? Because remember, I wasn't very confident about my 10. We could put a 1 into the function. That's what the remainder theorem says. So I could have done 1 to the 4th minus 3 times 1 squared plus 12. That's pretty easy to do, right? When it's a 1, I get 1 minus 3 plus 12, which is negative 2 plus 12, or 10. So did it check? Okay. So all that question was trying to get you to do was to see that you can check that by plugging the value in. All right. Now we're talking about using that factor theorem when I have a really disgusting polynomial like this. It is a degree 4 polynomial. They want to know, is x minus 1 a factor? Just look up here real quick, guys. That means you would put a 1 in. They did synthetic division and they got a 48. So is x minus 1 a factor? No, because it gave me a remainder. Is x plus 3 a factor? Well, they went back to the original polynomial. They put in a negative 3. They did the synthetic division, and they got a 0. So, yes, x plus 3 was a factor. And so they said it could be factored x plus 3, and then they took this depressed polynomial and turned it back into a polynomial and said it could factor like that. Now, I'm not finding that particularly helpful because I still don't know how to factor 4x cubed plus 9x squared minus 2x plus 1. Okay, but at least we knew one of the factors. All right, we are going to do number 6. It says find each f of c using synthetic substitution. Okay, so which way do you want to do it? You want to put the 4 in. Synthetic substitution means synthetic division. You want to do it by synthetic division. Some of you can just type it in. Somebody type a 4 into all that for us. I'll go ahead and do it this way. Did anybody do it this way? I didn't. What is that supposed to say? A 6, isn't it? I don't think that's 58. What did I do wrong? Oh! Thanks! Yeah, that would be why I didn't get anywhere near the right answer. It was x minus 4. Help! Okay, 2 times 4 cubed minus 3 times 4 squared minus 6 times 4 plus 2 was indeed 58. So, is this a factor? No. The remainder was 58. Or f of 4 was 58, not 0. Questions on that? Okay, moving on to number 7. Use the factor theorem to determine if the binomial given is a factor. So, what do you want to do? We can plug it in. Actually, they want us to factor this, so I think we should probably do what? Synthetic division. Okay. What goes in the box, guys? Negative 5. And across the top? 1, negative 2, negative 29, and 30. No placeholders needed. Okay, do the synthetic division. I'd feel better if I saw everybody's pencil moving. Number 7. It says we were given that it's a factor, I think. So it should come out 0. Did everybody get it to come out 0? By the way, I'm just going to say this once. If you're listening, you'll be really happy later. If you do a question like this on the quiz, it says completely factor this, you find out you have a 0, you plug it in, you get it, and you're doing synthetic division and it doesn't come out 0 when you know it's supposed to, bring your quiz up to me even and say, I know this is supposed to come out 0. Something's wrong. Because I don't know about you, but I can multiply 1 times 5 10 times and get 3 or something. You know what I mean? Once you do it wrong, you just keep looking at the problem. Or 3 times 2 is 5. That's always a good one, right? So if you've looked at it and you're like, I know this isn't right, something's doing wrong, bring it up. I'll see it. Oh, your mistake's right here. I'm not going to fix it, but I'll tell you where it is, okay? All right. They want us to factor this, so we have x plus 5 as a factor, because we did this and it went in evenly. What's left down here? X squared minus 7x plus 6. Does that factor further? How does that factor? So by synthetic division and our little pea brains, we discovered that this cubic could be factored as those three factors. Does the leading coefficient work? If I multiply them all together, I get back to a 1x cubed, right? Okay. All right. This is an extra example that you don't have. It tells us these two factors. You have one like this on your homework, I think. All right. Which one do you want to do first, guys? Doesn't matter. Do this one first. So what goes in the box? Okay, talk me through this really fast. Bring down the 2, then what? Tell me what to write. -8, -9, 36, -5, right? 20, and 0. Okay, what is this called right here? Yes, the very depressed polynomial, okay? It is called the depressed polynomial. What, guys, please pay attention. What we are going to do are called successive divisions. I don't know necessarily, I do on this problem, how to factor this. But if I know this is also a factor, I can keep going. I don't go back and do a divide into this again. I can keep going. What would go in the box? X minus 5 would put a positive 5. Keep going. Bring this one down and now do what? 5 times 2 is 10. 1, yes. Times 5 is 0. Okay. Does anybody know what the three factors are of this polynomial now? X plus 4, x minus 5, and 2x plus 1. Everybody see that? Okay, let me tell you what would happen. Someone will get out their graphing calculator, and they will look at the calculator, and they will say, ooh, it has a 0 at -4, it has a 0 at 5, and it has a 0 at -1/2. They will write x plus 4, x minus 5, and x plus 1/2. What is wrong with that answer? If I multiply that all back together, I get an x cubed. I am missing what? That leading coefficient, which you can just put out front as a 2. These are equivalent, okay, the blue and the red. But if you just look at your graphing calculator for the factors or the zeros, you'll probably put down the wrong leading coefficient. All right, you have this question on your worksheet, yes? It says to graph first. I'm going to ask you to do that real quickly only because if you just watch me, I'm afraid you're going to forget. Some of you need to turn your stat plot off probably, okay? If you've been doing other stuff. So type this horrible equation in y1 and see if you can get it to graph. 3x to the 4th plus 8x to the 3rd, arrow to the right, minus 15x squared, minus 32x plus 12. And then do a zoom 6. If it's not graphing anything or it's giving you an error, you may have a stat plot turned on. Otherwise, this is what I got when I did a zoom 6. Anybody not getting that? Can I help somebody? Or you may have typed something wrong if it's not looking like that. We were supposed to use that to determine which of these are zeros. Now, the first one said x minus 1, so I did trace 1. Can you type trace 1? Is that a 0? Look at my screen down here. What did I get? Did you get -24? Is that a 0?
Nope.
So this is not going to work right here. X minus 1 is not going to be a factor. How would we test if x plus 2 is going to be a factor? Yes, -2. So type -2, enter. Did you get a 0? Okay. Now if you do what? To test if x minus 2 is a factor, type 2, enter. Did that work? Yes? Okay. Now we're going to do successive division to find the other 2 zeros that are here, because at least one of them is looking pretty ugly. And this is how you're going to have to do this on the quiz. All right. So which one do you want to do first? The x plus 2 or the x minus 2? Doesn't matter. X plus 2? Okay. So what goes in the box? -2. And across the top? 3, 8. -15, -32, and 12. Okay, help me out, guys. 3. Then what? -6, 2. -4, -19. Then what? +38. 6, -12, 0. This is where you're supposed to know it's a 0. And if you mess something up and you can't figure out why it's not coming out 0, this is where you bring it up to me and say it's not working, okay? Now, successive division means we don't go back to the original one. We keep going. What are we going to try next? We also know from the graph that x minus 2 was a 0. So what goes in the little box this time? +2. Keep going. Don't go back and start over. 2 times 3 is 6. 8. 24. Okay, what did I do wrong? 2 times 8 is not 24. There you go. I'm like, it's not working. See, this is where you do silly things. I'm just modeling for you how to do something silly. 2 times 8 is 16. -3, -6, 0. All right, if they wanted all the factors, could we find them now? Maybe. What is this down here? 3x squared plus 8x minus 3. Anybody think they can figure out how that factors? What do you got? Oh, guys, let's check him. There's -1, +9. Is that going to be 8 in the middle? And -1 times 3 is -3. I think you got it right. So final answer? Okay. Are we good that that's the final answer or not? What is the last thing you want to check? That the vertical stretch. Is the stretch right or the leading coefficient right? If I multiply all that back together, will I get a 3x to the 4th in front? Yeah. Because we had the 3 in here, right? If we had just looked at the graph and found all the zeros, we probably would have written x plus 2, x minus 2, x minus 1/3, and x plus 3. And then we wouldn't have had the right stretch. We would have had to go back and say, well, A is supposed to be 3, so we can throw it out front. All right. But you have to show work on the quiz anyway. All right, recapping what we did today. The remainder theorem says that if you want to find if this is a factor, okay, you can plug it in, and if you get out a 0, then it's a factor. If you divide and you get 0 as the remainder, it's a factor. If you plug it in and you look at the graph, it will be an x-intercept. That will make it a factor. If the remainder is 0, and you set the whole equation equal to 0, that is also one of the solutions. All right. These are the 5 questions assigned. Does everybody have out a sheet of paper? We already did number 8, right? We're going to do 2 more, so you can put them right at the top. You don't have to try to figure out where they would go numerically. But I want you to add number 53 right now to the homework. It wasn't on the original assignment, but we're going to do it together. Unless you want me to stop and let you have the last 8 minutes for work time. What I'm thinking is let's just go ahead and do these and then you get all hour tomorrow. Is that okay? All right. All hour tomorrow will be work time. Okay? And I'm going to tell you this right now. If you're not working on pre-calc and getting the homework check-in next week because you had some time, something from the homework check will be the last work day we will have this year. All right. 2 ways. Anybody think of a way we could solve for K on number 53? We're supposed to figure out what value of K works here. Put 2 in for X. Why? It says right here the remainder is 0. So that means when we divide with the 2, it should come out 0, yes? Or we could do this, and it should come out 0. Yes? Okay, let me just show you. Don't necessarily write this down because it's not that fun. If I do synthetic division, I'd have 1, negative K, 2, and negative 4 across here. I bring down the 1, I multiply, I get 2. What do I have to do here? Add, right? I'm adding. So I have negative K plus 2 times 2 would be negative 2K plus 4. Add that 2 and I get negative 2K plus 6. Multiply that by 2 and I get negative 4K plus 12. Add to this negative 4 and I get negative 4x plus 8. And that was supposed to equal 0. All right. I don't think that was their best plan. I think Skylar was right on the ball. He said, let's just put in a 2 for all the x's, and then we should be able to set the thing equal to 0 and find k. So can you put in a 2 here? 2 cubed minus k times 2 squared plus 2 times 2 minus 4. And what's it supposed to all come out? Set in the directions. The remainder was 0. Okay, solve that. For k. To get 2 or negative 2? 2? Everybody get 2? Okay. You want me to pause for 30 seconds so you can do 55? Because that is assigned. Are you going to remember how to do it when you get home? You don't want me to do it, or you want to do it now? What would you put in? Negative 1 for everything? And solve for k when it's equal to 0, right? So negative 1, be careful, that's negative being cubed, plus 4 times negative 1. Where did I get the negative 1 again? From down here. Minus, negative 1 times k, which will become plus 1. Plus 1 equals 0. So solve that and you should be done with 55. I'm moving on because I don't have a lot of time, and this is a really nasty question. I think it was negative 4. Did I get negative 4? Okay. We're supposed to do number 59 together. Look at this. 6x to the 5th. Whew, joy. We're supposed to first graph it, and then from the graph, figure out how to factor this thing. Can anybody tell? Well, I have a better slide here. Can anybody tell where some of the zeros are? Negative 6 looks like one for sure. The only other one I'm fairly sure is right here, which is what? No, because it's counting by 2's. And Guys, is that enough? 2 zeros if we have a degree 5? Not so much. I actually think, can you see it's doing a squiggle right there? I think we might have to do 2 more than once. All right, help me really fast. -6. Okay, 6, 13. I'm going to need someone with a calculator. Okay. 6 times -6 is -36. Adding is -23. I'm already stuck. 138? No? Okay. Minus 153. -15. Times -6 is 90. Plus 54 is 144. Times -6. Help. $816 or 60? -864, which would be -140 times 6, I hope is positive 840. Does it work? Okay. Now we got to do 2 successively, not going back to the original, thank goodness. 6 times 2 is 12, is -11, is -22, -37 times 2 is 50, 74. Just kidding. -74. So then it's 70 times 2 is positive 140. We're good. Okay. I think we got to try 2 once more because it was squiggling there. 6 times 2 is 12. 1, 2, -35, -70, and 0. Okay. So far, it factors as x plus 6 and x minus 2 quantity twice. And then I have 6x plus squared plus x minus 35. Anybody think they can factor that? I think it's a 3x and a 2x. And a 7 and a 5. 7 and 5 would be positive 15 and negative 14. Okay, there is the completely factored version for number 59. Now, because it was kind of, guys, because it was kind of doing a cubic shape there, I thought 2 was a 0 3 times maybe, but did it turn out that it worked 3 times? I think 7/3 is a 0. So if we had zoomed in, we would have seen a little better job what it was doing there. It was actually bouncing at 2 and crossing at 7/3. So tonight you got to finish up these. Work day tomorrow.